All right, let's keep going on these solve for x SAT problems. So what are we gonna do here? They tell us that a is equal to 2. So we're first definitely just gonna plug that in. And then look at what they do here. Whenever they give you answer choices like this, it's almost always that like if you solved this all the way through, you're gonna get 3 and 6. And in reality, when you plug them back in, only one of them works. So, and honestly, this applies just anytime they give you solutions. It's very often easier to just plug them in. So like for example, if we plug in 3, you see you get this. And you might think that works for a second, but 3 minus 2, the square root of 1 is just 1. But 3 minus 4 is negative 1. So that's no good. 3 does not work. So that lets us cross out that. And then that nearly just guarantees us that it's going to be 6. But we can check it real quick. 6 minus 4 is 2. 6 minus 2 is 4, and the square root of 4 is 2. So 6 does work. And if you find that one that works, don't need to try the other ones, because 6 works. So 10, you got to solve for t. There's no real shortcuts here, I don't think. You just got to do it. But anytime I see a fraction equals something like this, I'm always going to think about cross multiplying. So I'm going to have t plus 5. And then, of course, you got to distribute the 10. So 10t minus 50. And then subtract, just get the t's together. So 9t, add the 50, 55. So t is 55 over 9. Which is dirty, but that's fine because that's one of the answers. All right. Now this one is a quadratic formula one, right? I mean, it's kind of obvious just by looking at it. So you could just go for it right away, but we hate fractions, right? It's nicer if you can get rid of fractions. And we can, because we can just multiply everything here by 2, both sides of the equation by 2. And then we'll go ahead and move the 4p over. So we've got 2x squared minus kx, and then minus 4p, because we multiplied it by 2, equals 0. And since that's squared, this is a quadratic, right? It's got more variables, but it's a quadratic for x, because that's the one that's squared. So the other ones we're just going to treat like numbers. So we're going to say, if we wanted to write it out, that a equals 2, b equals negative k, and c equals negative 4p. And then we just go for the quadratic equation, and that should be one of the answers. Or at least roughly, once we do a little bit more. So what do we get? Negative b, so k, plus or minus the square root of b squared, minus 4ac, so minus 2 times negative 4p, so plus 16, or no, times 4, so 32p, all over 2a, so 4. And is that an answer? It's not right away, but when you hard it and separate it into two different fractions, then it's an answer. Which is awesome. So then this one, for what real value of x is the above equation true? So you got a few different options for this, right? I would honestly immediately jump to synthetic division. If I was you, it might not be the best way to do it, but that's probably the most familiar way to do it. Because what do you do then? You just kind of try a few numbers. That's kind of what I'm used to. Except for, you can't try positive numbers because it's fill in the blank. So that means your answer has to be positive, which means the numbers for synthetic division have to be negative. So like maybe you try negative 1. And you go 1, negative 6, 6, 8, negative 8, negative 18. And you remember you're looking for 0. So that doesn't work. So maybe you try 2. And honestly, if you don't even remember the synthetic division, it's probably easy enough to just plug these numbers directly into the equation. But the synthetic division is probably a little easier. So we try negative 2. We get negative 7 here. And then 14. And then 16. And then negative 32. That doesn't work. And then if you remember the pattern, so maybe the synthetic's kind of nice, kind of not so nice. But if you remember the idea here, the possible solutions are the multiples of those. So 1, 2, and 5. So we've tried 1, we've tried 2. That tells us if it's going to work, it's going to have to work with 5. And we run through that. Mess up hard. That's a -5, so that's a -10, so that's a 50. Why am I screwing this up so hard? 1, 1, -5, -10, 50, 52, and, well, that sure as heck doesn't work. So what is going to work then? I really thought that one would work. Why didn't that work? 1, -5, -10, 50, 52. All right, well, maybe synthetic division's not the way then. So what is the other way? The other way is to use factor by grouping, and to notice that here you can factor out an x squared. Here you can factor out a 2. And then after you do that, look how they both have an x minus 5. So you can factor out an x minus 5. And you end up with this. So when you need that to equal 0, you set both of those equal to 0. And that's why you get that x equals 5. And that's the answer. And if you plug it in real quick, you can actually very easily see that that's true. Because here 5 cubed and then 5 times 5 squared. So those just go away. And then 2 times 5 minus 10, that is definitely 0. Which begs the question, why were we failing so hard on that synthetic division? So what is it supposed to be? 1, -5, 2, -10. So, oh no, because the solutions go on the outside. Oh, I told how to do synthetic division totally wrong. The solutions of synthetic division go on the outside. So +5 will work, but we were actually trying -5 last time. Oh no, that's big problems. But that's what I like about this, is that, and that's what I like about math, that if you do something wrong, you can realize what is going wrong. You can realize that there is a problem, and then go back and fix it. The number that you put on the synthetic division is not the opposite sign of the solution. It is the solution. It's the opposite sign of what goes in parentheses. Now it's coming back. It's been about a year since I talked about this. But you do see factor by grouping. That is just quicker, especially if you just notice it. If you know that that's a tool you can use, and maybe just see that if you factor out the 2, that gets you the 5 that you want here. It's nice when you can pick that out. All right, so now we got one of these. So let's again not read too much. Let's not read at all. Let's just go to the question. For what number of days X will the total cost of buying materials and renting tools from store B be less than or equal to the total cost of buying and renting materials from store A? All right, so equations. Writing equations is always the move. So what is our equation for store B? How much does it cost? Well, it costs $600 just to buy the materials. But then we also have to pay for the rentals. So it's $25 for the wheelbarrow and $80 for the concrete mixer. So you add them together, that means we're paying $105 every day. So 105 times the number of days. Can I do a pure math paper? Yeah, definitely. If you tell me where to find it, and if you're still here, yeah, I definitely can. I'm not good at reading the TikTok chat. I'm better at reading Twitch chat. So I don't know how long ago that was. But yeah, if you tell me where to find it online. Or you can send it to me in my Discord. So the Discord is for questions. mathlab.online/Discord. I didn't pause this recording. I get so distracted when people ask me math questions that I just stop everything I'm doing. Okay, so let's finish out this problem. So this is our equation for part B, 600 plus 105D. Now we want our equation for A, which is the materials cost, $750, plus the rental cost. So it's 15 plus 65 a day, so that's 80. a day. So those are the two equations for the cost. The one for the cost B and the other for the cost of A. And then what do we want? We want when B is less than or equal to A. So we can just set that up. We can say that we want 600 plus 105D to be less than or equal to the other equation. And then now look, we just got an inequality. We can just solve it for D. So we just got to subtract 80 from both sides to get 25D and subtract 600 from both sides to get 150. And so whenever we're using less than 6 days, we should be using store B. And anytime we're going to use more than 6 days, we should be using store A. That's awesome. And then here, this is one of those where we could do the same thing and figure out what P needs to be, but it's going to be better to just build this, because what do we have to do to make that into that? We just got to add 4 to both sides. So we have that 3P plus 2 is greater than or equal to 5. So what is the least possible value of 3P plus 2? 5. Beautiful. And we're going to have to make this into another part. But thanks for paying attention to this one.